Hello everyone. In this session we continue our neuro fuzzy systems. In last session I told you about basics of a neuro fuzzy systems. Neuro fuzzy system basically it's a combination of two systems, artificial neural networks and fuzzy logic system. One system learns from the data and try to interpret, predict new things, where other system guide us in taking decisions in an uncertain environment. So we are combining these two systems together. You can combine several ways. A fuzzy system first gives the input to the neural network. This is one way of combining. Another one, a neural network gives input to a fuzzy system. This is a second way of combining. So based on the requirement of our application, our nature of our application, how it reasons about the output, we choose either one of these two. Either we can go for a fuzzy system, then it gives to the neural network. So basically this is the structure. We can show how these entire things work. First, a crisp input is sent to the fuzzification. Now in logic I told you there are two sets, crisp set and a fuzzy set. Crisp logic works with the crisp set, whereas fuzzy logic works with the fuzzy sets. Now we give we have to give a first step is we send this crisp data to the fuzzification. Let us see small. As I told you, neural networks, we have three layers. This is input layer, hidden layer, output layer. Each neuron process the data, process some kind of a data and send it to the next neuron, next layer. Means it is trained on performing some action on each feature of our data. Now when I send a crisp set, suppose I take one example. In previous example I told you some restaurant example where there are two inputs. Suppose a waiter, when we go to restaurant, waiters serve the food, and we also say service, and we have to decide one tip, how much tip we should give it to the waiter. And I told you some rules. If food is bad, service is bad, we give low tip. If food is good, service is bad, we give average tip. If both are excellent, we give high tip. Now these are three rules we defined in our fuzzy logic base. And what are the input to my system fuzzification is food and service. These two will become the crisp input of my fuzzification process. Now fuzzification, after this, each one is sent to, features of each input is sent to one of the input layers. Suppose this input, this neuron may receive features of a food, this neuron may receive features of a service, features of this one. Now after processing, along with the rules are sent at member functions assign values to these features. Means we some features of we give some weights to each one. Okay, suppose a food is delicious, there's maybe some features that tells this food is delicious. Suppose a service is good, what are the features that decide that service is good? Service is bad, what are the bad? So we assign some weights. These weights are decided by our membership function of that fuzzy logic. And this process we go. Based on this one identified pattern, again we send it to the new bias is added. New weights are sent to the neuron. Again this neuron decides, again it applies some member function and it gives the new values to these weights. Finally, your output layer combines all these things and finally decides the like tip. Means first crisp data is sent to the fuzzification are sent to the each neuron of neurons of input data, and that takes the membership function, it takes the rules from this one and decides the weights, and defuzzification is performed. How much step it, how much final value that is converted into the crisp output through the output layers. This is one simple, a small example how fuzzy system and neural network are combined together. This architecture it goes. Next, when we are combining, how we combine these two systems? There are three approaches of combining neurofuzzy systems, types of neurofuzzy systems. First approach is how if we combine fuzzy system with the neural networks. First approach is cooperative approach. In cooperative approach, what it means, one fuzzy system works independently with the neural network system. Means both of them they work independently. So if fuzzy logic takes care of one aspect of the application, whereas your neural network takes another aspect of the application, so then we say that that application is a combination of cooperative approach, they are combined together. Similarly, another way of combining is concurrent. Means if they are concurrently they are working together, they follow one sequence. Fuzzy logic output is sent as the input to the our neural networks. Our neural networks output is sent to input to our fuzzy logic system. Means they work in a sequential manner, either pre or post processing steps, one by one. So this is second approach of combining together. Third one is a hybrid approach. In hybrid approach, we don't identify that they are separate entities. A fuzzy system itself can be interpreted as a neural networks. If you say neural network means internally fuzzy membership functions work at each neuron. Means hybrid means we can look it as one single entity type. So in these three ways you can combine both fuzzy systems and neural network systems. So here what are the different applications? Means how inputs and weights are arranged for different requirements. Based on the weights, inputs and outputs, suppose it is a type 0 type of NPS, means your weights are crisp. Means crisp means they are not generated from our member function. You give fixed values, crisp set. Inputs are crisp, outputs are crisp. That is not this is for a normal logic environment. But fuzzy logic means weights are crisp, inputs are fuzzy, output is also crisp. This kind of interpretation type, this kind of arrangement we use for application that require classification, where we categorize classes, means where we predict that a particular data item belongs to a particular class. In such kind of applications, they use type 1 where weights are crisp, inputs are fuzzy and outputs are crisp. Applications, main application that say if this go to perform this kind of if then kind of rules, if you require, they change their weights are crisp, inputs are fuzzy, outputs are fuzzy. So output is also fuzzy if you expect. There are some combinations where unrealistic applications, means where everything is fuzzy. Those kind of NFS also we can develop based on our application requirement, weights, inputs and outputs we choose which is better for us. And models, how we have two kind of models of this NFS, fuzzy systems, neural networks followed from fuzzy systems. So Linguistic statements first, these are sent to, like this is also our concurrent type of applications. They use this linguistic statements sent to fuzzy interface. Fuzzy perception neural inputs are sent to neural. Then decisions are sent. Means first we apply fuzzy system, then we go for neural system. This is one model. Second model, first we apply the neural network output is sent as input to the fuzzy. Here we send a fuzzy logic output as input to neural network. Here I am sending a neural output to the fuzzy inference and take decisions. In this way you can either choose one of these two as per our requirement. So like this, these two are combined, and we can prepare several neuro-fuzzy models. So let us see some applications where NFS neuro-fuzzy systems are used. Now one popular application that many of us can experience is Sanyo companies, Japan. They prepared one electric fan that rotate towards the user. Means wherever, suppose the electric fan user is moving, electric fan is also moves towards this direction. Here because it is uncertain, means the user in which direction he moves, that is handled by a fuzzy logic. And what are is by learning that user's previous data, means how his behavior, how he moves, in which direction generally moves, that is trained by our neural network. That model is currently employed by the Sanyo company to prepare electric fan. That is also example of NFS. Adjusting exposure in photocopy machines, improving the rating of a convertible bonds, financial pay also they are using this one. So wherever both learning and decision in uncertain environments are involved, they go for developing NFS model. Measuring opacity, transparency of water in washing machine, Hitachi also using this NFS model in their application. So in next session we go for what are the different approaches of developing this NFS models. Thank you.